Okay, taking a look at number 4, they tell us that in this diagram, AC is a diameter of our circle, and if the slope of BC is 1/2, what is the slope of AB? So this is something that we talked about briefly in class but didn't spend a ton of time on. If we are looking at, this is our diameter in the circle that takes our 360-degree circle and divides it into 2 equal pieces. So that means this side over here of the arc from A to C is going to be 180 degrees, and then also this side of the arc, the whole thing from A to C is going to be 180 degrees here. So what that means is when we take a look at this angle right here, this inscribed angle that intercepts that AC arc of 180 degrees, this is actually going to end up being a right angle. And that is true every single time you have a diameter and then you have pretty much a triangle where the hypotenuse is the diameter. This is always going to be 90 degrees. And while if we've got this is 90 degrees, and we know that BC is negative 1/2, and this is perpendicular, or 90 degrees, then how is the slope of AB, what is the number going to be with it compared to AC? And that should get you through that one. Taking a look at the next one. Taking a look at number 5, this again will use, it tells us that BD is the diameter of our circle, and it tells us that if AC is 30, what is the measure of angle DBA? So with this one, we know this one is 30. What we want to solve for is the measure of angle DBA. So if I look at that angle DBA and I trace it out, so there's AB, there's DB. If I look at this angle intercepts this arc over here. So the reason why I'm looking at arcs is because I'm focusing on this angle of 30 that they give me to work with right here. I'm looking for this angle intercepts the arc, so I've got to find some way for this angle to kind of work its way over to being this angle. So I took the angle out, looked at the arc. I didn't have the arc. It would have been nice. It would have made things a lot easier for us, but they didn't. So then I'm looking at this 30, and I'm looking at extending this angle here. And if I extend this angle, I notice that it intercepts this arc here, AB. So then you've got to think about that relationship between this inscribed angle and this intercepted arc. Remember how they're related. And then once you get whatever this number is right here, you can take that number, and if you look from here all the way over to here, we talked about the diameter creating a semicircle or 180 degrees. So if we're able to find this one, that lets us be able to take this angle, this arc, subtract it from 180 degrees, which will give us this arc right here. And then once we have that arc, we can take and do whatever math we need to do with it, whether it's to multiply it by 2 or divide it by 2, to take it down and have it be equal to that angle right there. Looking at the next slide. 6. This is another relating angles to each other and remembering the rules kind of a thing. So they tell us that point O is the center of the circle. They tell us that our angle ADB is going to be 43 degrees. And then they tell us that if AOB, so if I outline my AOB, so this guy right here is going to be equal to my BOC, that guy right there, what is the measure of angle BDC? So I'm looking for BDC. So this is another one of those, You've got to figure out all the relationships to start from here and kind of work your way over to that direction. So if we start kind of looking, the only thing that we have to work with to start with is going to be that 43 degrees. That's all we've got. So we've got to make that work. So remember how 43, we've got this 43 for this angle right here. It's going to be related to this arc right here. It's going to intercept that arc. So how is this angle related to this arc? And then the other piece of information that they give us is right here. This is kind of like our bridge between going from there to there. So, well, I know this angle is related to that arc. And I also know that this angle right here, the central angle, is related to this arc. So whatever this arc ends up, the measure of that arc ends up being, how is this arc related to this angle? So once you figure out how those two are related, this angle right here is going to be equal to that angle right there. And if we look, this angle intercepts this arc. And also that arc, so this angle intercepts this arc right here. And then also the angle that we're looking to solve intercepts that arc as well. So you need to figure out how this angle is related to that arc. And then once you get the number for that arc, you can figure out how this arc is related to that angle, and that will help you get from having this angle here of 43 to knowing the value of that angle right there. Looking at the next one. Looking at 7, this takes it a lot further than what I'm looking to have you do with the way things are right now. So looking at those two drop downs, you're going to have the first one be supplementary and the second one is complementary. Looking at number 8, that one is going to be 1 and 2 for the first statement and the second statement. Looking at number 9, looking at which step for constructions, you're looking at D, drawing a line through D that is perpendicular to one of those three sides. Looking at 10, that is going to be located at the center of the inscribed circle of the park. So that fountain should be at the center of the inscribed circle of the park. Looking at 11, this is one where we're looking at an inscribed quadrilateral, and this is you draw the picture and it gets a ton better. So I'll get you started on the picture. So if I draw a circle, quadrilateral ABCD is inscribed or written inside that circle. So I'm going to go A, I'm going to go B over here, C here, and then D there, and then connect my lines. And then it tells us the measure of angle A is 64. It tells us angle B is going to be 6x plus 4. And then C is 9x minus 1. And then the answer that it's looking for is, what is the measure of angle D? So if we remember our rules for inscribed quadrilaterals, the opposite angles are going to be equal to 180 degrees. So you've got to have two things added up to give you 180 degrees. So pretty much we could say that angle D plus angle B would be equal to 180 degrees, but then we wouldn't have something to put in both blanks, and we can't put an X here because they didn't put X here in the problem, and you can't just make it be X because you don't know for sure that what that angle is the same as what would need to go in here. So that's not going to work. So that leaves us with needing to work with the two angles that they do give information for. So to start off with, you're going to need to do angle A plus angle C be equal to 180. And whenever you get that plugged in and all said and done, just kind of as a checkpoint to you to make sure that you're along the right lines, you should be getting x is equal to 13 is what I got. Okay, so once you get that x is equal to 13, you can take that 13, plug it into there, and that will give you the exact value of what B is. So then you know what angle B is. So then you can take that number that you get for angle B, and I'm going to let you do that on your own. I don't want to spoil the surprise for you. But you can take that, plug it in, get your angle B plus the angle D is equal to 180. And then you can take this number, subtract it both sides, and that will give you your angle D, and that'll help you get through that problem. Taking a look at 12, again, this just takes it far more than I'm wanting you guys to work right now. So that one is going to be 4.5. Looking at the next one, 13. And then taking a look at the next one, this is another one that is a good one to do. You just have to go through and label the things that you're working with. So if we're looking, AC is 5, BC is 12, and then AC, so this arc. So I'm actually going to scooch this guy on the inside so I'm not confusing it between other things. Usually I like to put these side measures on the outside, but they gave me an arc right beside, so I'm going to scooch it on the inside. So I've got 45.2, and I'm going to put a degrees to help me remember that that's for an arc. So then it says to the nearest unit, the radius of the circumscribed circle is how many centimeters? So you should be able to find that. Now this is being a little tricky because if you look, remember what I told you about those triangles that have one of its side being the diameter, that this is going to be 90 degrees. You're going to have a right triangle. So in order to be able to find this side right here, you would have to use Pythagorean theorem. But then if you use that Pythagorean theorem, that gives you a diameter that doesn't give the radius. So don't do Pythagorean theorem and then plug in whatever number you get here. That's not gonna work out for you, because that will solve for the whole entire diameter. When you use the Pythagorean theorem, they want the radius. So they only want half of it. They only want, and it doesn't matter which way you go about it, but they want either this side right here or that side over there. So careful with that one. And then the measure of angle OAC. So this is another, they want this angle. The closest thing related to that angle in this circle is going to be this arc right here. But they do give us this arc. Remember what I said about diameters. Diameters make how many degrees? Yep, it's going to be that 180. So you've got to use what you know from here, subtract to get that one right there. And then remember the relationship between that arc and that angle right there, and that will give you that number that goes right there. Looking at the next one, looking at 15, you're looking at 24.5 and 45.68. Looking at 16, that one's going to be 4/3. Looking at 17, they're having you do in radians. We don't do radians with this course. So you're looking at 3.77. Looking at 18, what is the area of the pool rounded to the tens place? So with this one, I could have, if they just had you find the area of these sectors, I would be okay with it. But, and then even on top of it, they're having you do radians. And like I said, we haven't worked with radians, and I'm not going to have you do radians. So you're looking at 2,490 square feet. Okay, taking a look at 19. So looking at this one, we've got a transportation department has put railing around the outer curve of this road. The road is 20 feet wide. What is the length of the outer curve to the nearest foot? So this is one where you're looking for, and the key word here for you is length. What is the length of the outer curve? So if I go look at what we've got, this is the outer curve. So if we look, if we were to continue that, we would end up with a circle. So we're looking for the length of a part of a circle. So this is arc length is what we're looking for. And so if I go and I create my radius with what we're looking for, there's our radius right there. So we're looking at 70 degrees, and then the whole radius is going to be 70. So from there, you need to use your arc length formula to figure out. We've got 70 over 360 times 2 pi r, and that will give you that length right there. Taking a look at 20. Taking a look at this one, that gets more into formulas than actual calculations, and that's more of solving a formula that hasn't had stuff put inside of it. So we're looking at that one. That's going to be 7 squared divided by r squared. Looking at 21, that is going to be switching from one form of a circle to the other, and it's got fractions in it, and I'm not going to make you do fractions for those. So 1/2, 1 is going to be your center, your radius is going to be 2. Looking at the next one. So with these, this one's not bad at all. This is, you're going to take your equation for a circle from general form and either plug it into the GeoGebra or go ahead and just complete the square the way that we did in class. Looking at the drop downs, using the drop downs. And this is to the second, just pick whichever one you feel is the best answer, and then based on what you pick from there will be what you pick from here. Remember that the numbers here will be similar to the numbers that you're seeing in here, but not exact. Remember that whole opposite on the inside thing. And then the answer for this one I felt was a little confusing, and I didn't like the way they worded it. So the answer that you're looking to go in that box right there is that one. 3 times 2 to the 1/2. Looking at 23, this gets into a lot of theory. So that one is going to be A is 1, B is 1, C is 0, D is -8, and E is 7. And then looking at 24, C and D will stay unchanged, but E is going to increase. So that will help you get through the problems that you may see for these. I hope it helps. If you've got any questions, let me know. Send me an email or pop in during my virtual office hours. Take care.